Hello everyone, welcome to my YouTube channel. Let me introduce myself. My name is Stendro Yehezkiel Manongga, with student ID number 251011030031, usually called Stendro. Every day we often use digital devices, starting from the simplest ones like calculators, to computers. Although there are so many digital objects, which have different functions, the fact is they all work on the same principle, which is active and inactive, which can also be symbolized by 1 and 0.
Here is a truth table, where in mathematical logic, the value 1 represents true and the value 0 represents false. If P equals 1 and Q equals 1, then the result is 1 true. If P equals 1 and Q equals 0, then the result is 0 false. If P equals 0 and Q equals 1, then the result is 1 true. And if P equals 0 and Q equals 0, then the result is 1 true. For example, if it's raining, 1, and you bring an umbrella, 1, then your plan to go out is correct, 1.
The part that works like this is called a transistor in electrical installations, also known as binary numbers in computers. But how do transistors work just by being active and inactive? Therefore, in this video I will explain the concept of computer logic, which is the foundation of the operation of every device we use every day. As explained earlier, transistors work with two conditions, namely active and inactive. First, we will discuss the NOT gate. This gate can be said to do the opposite of the input given. Imagine there is a bottle. When this bottle cap is opened, input inactive, the contents of the bottle can be poured out, output active. But when we close this bottle cap, input active, the contents of the bottle cannot be poured out, output inactive. Now we will look at this installation. When I activate this switch, the light in this room will turn off, whereas when I deactivate this switch, the light in this room will turn on. After the NOT gate, we will continue to the AND gate. Imagine there is a fan. In this condition the fan is completely inactive, but let's try connecting the cable to the power source. First input active, without pressing the button on this fan. Second input inactive, the fan will not turn on, output inactive. Now let's try leaving the cable disconnected. First input inactive, and pressing the button on the fan. Second input active, the fan still won't turn on, output inactive. But when we connect the cable to the power source, and press its button, first and second input, active, then the fan will turn on, output active. Now we will look at this installation. When I only activate one of these switches, the light in the room will not turn on. But when I activate both of these switches, the light in this room will turn on. Finally, we will discuss the OR gate. Imagine you go to a restaurant. When you don't order anything, first and second input, inactive, your order cannot be processed, output inactive. Now you order food, first input active, and you don't order a drink, second input inactive, your order can be processed, output active. Likewise, if you don't order food, first input inactive, but you order a drink, second input active, your order can be processed, output active. When you order food and a drink, first and second input, active, your order can still be processed, output active. Now we will see this installation. When I only activate one of these switches, the light in this room will turn on. Likewise, when I activate both switches, the light in this room will turn on. But when I deactivate both switches, the light in this room will turn off. After the discussion about logic gates, it can be concluded that the NOT gate will give the opposite result of what is given. The AND gate will only be active if both, or all, of its inputs are active, while the OR gate will be active as long as one of its inputs is active. So that's how transistors work, and that's the foundation of all existing digital devices. That's computer logic. Thank you for watching. Goodbye.
So guys, I move first with this object. I want to use blender, but let's go. I have done with these two objects.